Here's problem 2611. In the figure, if C is equal to 5 microfarads, C2 is 15 microfarads, C3 is 30 microfarads, and the voltage of the battery is 24 volts, what is the total energy stored in the three capacitors? It's kind of hard to see on here, so we have C1 is 5 microfarads, C2 is 15 microfarads, C3 is 30 microfarads, and then the voltage of the battery is 24 volts. You know, if we were to figure out the energy stored, and we know that energy stored in any capacitor is going to be 1/2 C times the voltage squared. If we were to figure this out individually for the three capacitors, we could add that together and get the total energy stored by the three. But any equivalent circuit should have no different effect on the battery than any other representation. So if we could find the equivalent circuit for this network of capacitors and find the energy stored in that equivalent capacitance, that would be the same as finding all the energy stored in all the individual capacitors combined. Let's do that. So let's simplify the circuit first. Looking at this, we have a series combination of a 15 with a 30, so there's only two of them, so C series will be equal to product over the sum, 15 times 30, or 15 plus 30. That'll be 450 over 45, or 10 microfarads. Based on this, our circuit now looks like this. We have a 5 up here, a 10 in the middle representing those two, and then we have a 24 volt battery. Well, we have two capacitors in parallel now, so our C equivalent for this whole circuit is going to be 5 plus 10, or 15 microfarads. So now the circuit looks like this. One equivalent capacitance with a battery, 24 volts, across 15 microfarads. Well, if I were to find the energy stored in this equivalent capacitance, I would say, go back here, that the energy is 1/2 C equivalent times the voltage across that squared. That's going to be 1/2 times 15 microfarads times 24 volts squared, and that will give me what? 4,320. I know I have a micro still in there, so this is going to be microjoules. 4,320 microjoules, which I could write as 4.32 millijoules. And that would be the energy stored in this whole circuit. In all three capacitors combined, that is represented by the equivalent capacitance. That is the total energy stored in the three capacitors.